This is part 6C on the duct design video series. In this video we're going to examine return air number 3. If you can notice, the symbol here is a single diagonal dashed line. That symbol tells us that this return air actually originates on the first floor. And so if we look on our first floor layout, we can see that there is a return air here, and so this return air is going to become R3. Typically on the ground floor, we place the return inlets in a low wall position so that the top of the grill itself is approximately 12 inches or so above the floor level. The air is then drawn through the grill into the stud space, drawn down through the stud space into the floor joist below in the basement, then drawn through the joist spaces into the duct, and then back to the furnace. So let's examine the parts that are in this particular return air. So as mentioned, it is a low wall grill, and so we would use a fitting that would be this grill fitting here, which is a grill on the wall. So it would be a D fitting, and the associated equivalent length is 10 feet. And so for R3, we've got our D with the 10 feet. Now our stud to joist is the point here where the return air comes through the plate opening from the stud into the joist and then turns and makes its way over to the duct. At this point, we have a duct fitting which is equivalent to this A15. You'll notice that the floor joists are running perpendicular to the direction of the wall. And so because our return air simply comes straight down and then turns at a 90 degree going into the joist space, we can use this A fitting. As well, because the return air originates on the first floor, there will be only one turn from the stud into the joist. And so therefore, we would have a single A fitting with the equivalent length of 15. The next is the turbulence. As the air now travels into the duct at R3, it turns and heads towards the furnace. We've got this transition, and so the transition has the effect of starting the turbulence over again. So in fact, R3 does not experience any turbulence at all. So there's why we have a 0 in the turbulence column. However, we do have a duct to joist, or in this particular case it's more accurate to say joist to duct. The air is flowing through the joist into the duct, and so we need to assess the equivalent length at that point. And so this is where you need to determine, is the return air entering the duct at an extreme end, or is the return air entering the duct somewhere in the middle? In other words, between the furnace and the most remote return air. In the case of R3, we can see that it is entering the duct approximately in the middle between the end return and our furnace. And therefore, you would have to use the A2 fitting with an equivalent length of 60 feet. And so here is the A2 with the 60 feet. Once again, we have no trunk fittings. We do have the transition, and so we once again show the transition And once again, we've got our expanded collar, and we've got our plenum takeoff, or typically known as a PTO. Now we need to measure this return air. As I mentioned, the top of the grill is approximately 1 foot above the floor level, so we can automatically add approximately 1 foot of vertical height in the wall. Now we are in the joist space, and so we need to measure the horizontal distances. And so once again, I'm getting approximately 2.5 feet. And then this horizontal distance from the center of the drop duct to the center of R3 is approximately 6 feet. So therefore we've got 8.5 feet of horizontal distance here, plus the 1 foot in the wall, so that makes 9.5 feet. And then we've got our 7-foot drop, which would be a total of 16.5 feet. Once you've determined all of the individual distances and we come up with 16.5 feet, at that point you would simply round up to 17 feet. Then if we add all of these equivalent lengths plus the actual length, we should come up with an effective branch length of 162 feet.